Hi, I'm Greg Alcar with Pronk Technologies, and I wanted to do a quick presentation for you on our newest product, the SafeTSim electrical safety analyzer. Just a quick overview. We've got electrical safety modes, both manual and auto, and you've also got a simulator mode that you can select from the device. You've got 10 ECG snaps across the top with our patented banana plug grooves that allow you to hook up banana plugs from an EKG card directly in underneath the ECG snap to get a solid connection. You've got your input power connector there. You've got a nice handle at the top to grab it and go. We've incorporated bracket assembly that allows you to clamp it to anything you need to, or you can take the clamp off. It's the standard camera size mount, so you can actually use any clamp you like. We offer a couple different versions of a pole clamp that you can use with it. It can run on AA batteries, particularly for simulation, but also for ease of testing. So when you go from room to room, you can stay on the same screen in between electrical safety tests as well. So what's really different about this product? We really focused on making it as small as the smallest handheld electrical safety testers around, but as smart as the bigger boxes that are very expensive in terms of making it capable of doing automated testing defined by the user. So if I hit the auto manual button here, you'll see what I mean. You can select the mode from this screen. You've got manual mode, which is very straightforward, and then you've got up to 5 automated profiles that you can define. Once you've set those up, you don't have to touch them again. They'll be there for you when you need them, and you can select the different profiles from this screen. If I run a test right now on this patient monitor, we can actually do an electrical safety test and a simulation on it. I'm going to plug in the power cord for this device into the DUT power outlet on the safety analyzer. Now I'm going to hook up my ECG leads ahead of time. Those are color coded, so you've got a much easier time hooking those up. In this case, I'm only going to use 5 leads, and we're ready to go. So I'm going to select the ES2 electrical safety test, and I'm going to show you a couple of unique features with the device. If I hit enter, I get the home screen for that auto test. I'm going to go ahead and clamp this down here so you can see it a little bit better. So from there, I hit start. It's running a ground test, and notice there's a flashing LED and an audible tone. The audible tone tells you that it is not yet seeing a passing value for the ground test. So the red LED also tells you the same thing. Until it senses that it's got a passing ground resistance, it's going to keep beeping at us and flashing that LED until we get a good value going back to ground. So now it's got a good value and it's moving forward. So this is an automated test that I named ES2. And you can see here it's moved on to earth leakage. Now it's on to chassis leakage, ground open. And it's giving us a green flash at both LED points for each test, telling us that it's passing those tests. Quick red flashes tells us that it's in ISO. So it's doing the ISO test on the snaps. And we're done. Quick and easy. I had set up the profile ahead of time so you could see 4 different individual tests run under automation. And at the end, you get a solid green LED both at top and bottom. You can actually see it from the sides as well. And that tells us, solid green tells us that every one of the tests passed and that we completed the testing. So from that screen, I can actually scroll down and see all the individual tests and the results from the measurement that was taken. On the left you see a pass or a fail with a P and an F, and on the right you see the measurement value. You can scroll through those if you need to. Let's run a quick test now where we're going to see a failing result. So I've set up ES3 profile with a low limit so that it will fail intentionally. There it is doing the test ground. It sees a good value for the ground resistance. It moves forward with a green flash. Earth leakage normal polarity is running now with an hourglass. It's done with a green flash. Chassis leakage failed. And it failed because I set that limit at 5 microamps, which is much lower than the standard of 300 typically. So we finished the test. One of the individual tests failed, so we've got a red LED glowing on the device in both the bottom and the top areas, so that you don't have to worry about missing a failing electrical safety test ever again. You can see it and you can hear it that something failed in that automated test. I can scroll down from there, find out which one it was. I've got a flashing F under chassis leak, normal polarity, ground open. One very unique feature that we haven't talked much about on the Safety Sim electrical safety tester is the ability for the safety analyzer to actually detect that it's being dropped. That's important because electrical safety testers have relays in them. If they're dropped and they hit the floor, it can cause a lot of damage to the internal circuitry of the safety analyzer. We put a lot of thought, time, and effort into designing it to be smart enough to sense when a drop was occurring before it hits the floor and actually shut down all the relays inside. That was done with a very accurate accelerometer designed into the circuitry, and a lot of work done on the software side to be able to read that accelerometer and know that the device is actually dropping. So I'm going to do a quick demonstration of how that works. We're going to turn on the tester, we're going to run an actual test, and I'm going to drop the device a couple feet so you can see it. I dropped it a couple feet, it detected sudden motion, and it aborted the tests, meaning that it shut down all the relays to make sure that no damage would be done to the internal circuitry of the safety analyzer. As far as I know, that's the first safety analyzer ever built that has the ability to detect a drop before it hits the floor and protect its own circuitry.